Hello, CET 103 students. I'm back again to finish out the second half of our lecture series on survey equipment. We've been talking about the GPS and the data collector system connection, the two pieces that go together. GPS being the surveying piece of surveying instrument, the data collector being the basically handheld computer that's doing the communications with the GPS unit. So I am going to go back and start sharing my screen again. And if you remember, this is where we last left off in the last video series. And we were talking about sort of the display on what sort of information you're getting out. So basically, good to reiterate where we were. Most GPS units will come equipped working in the WGS84 system, and at least any in the US here, and they'll have be giving you northing easting, and then the coordinate system would be northing easting ellipsoidal height is what we're getting. Now, if you want something different than that, like for example, you want northing easting elevation to come out, you basically would be in the ground coordinates, or you can choose to set this up and do this internally. And this all takes place internal, so it's more about what you're seeing on the screen, but you do want to make sure that your settings are all correct when you're doing that. Or when you're sharing data with that, whether it be an engineering firm, the clients, or even in this situation could be the contractor if they have their own equipment. You want to make sure that you're understanding that you're all talking the same language when you talk about communication. Next, I'm going to head into this is something that I always joke with. This is the TopCon system actually has what they call the audible alarm, I'm sorry. And the audible alarm basically is an alarm that says, it uses the term uh-oh when it loses lock or does something of that nature. And you're allowed to turn that lock on and everything. What I do like about the audible alarms is that if for some reason you've lost your position, you want to know that so that you're not trying to work in to get this particular point of work, and you're negotiating your way in or navigating your way in and find out that you've lost a satellite lock for some reason. So I do encourage that you find out how to turn your auto alarms on, and that you do in fact use them. Sometimes it may not be, it may be kind of a pain in the neck if you want to do it sometimes, but just knowing that that option is available. Okay, so now that we've got the job all set up, we're ready to go out and start surveying. So now I'm going to jump through. So here's how we're going to start. In this particular situation, we're going to be using the scenario as if we were using a base unit, a place where we have a point, and we're going to have the base unit find its location, and then we're going to give it the information, and we'll set the base unit up so that it's broadcasting the signal. And then what we're going to do is we're going to go to and get ourselves our roving unit set up so that we can then start communicating with our rover. So we would come over here into our data collector, and the first thing we're going to do is start up our base. So regardless of what system you start up, you want to start up your base or find your base to make sure your communications are taking place. In this situation, I tell it to start the base. Here you would see it's wanting to do something like define that base position. In this situation, I could put a descriptor in, give it a number. Oftentimes it'll count up with the number, the coding system, if that's something you have working for your system. Also notice right here, it's asking for your antenna height. If you remember from the previous set of slides I told you about, that was the height of the instrument to the ground, or to that position of that point on the ground. That's a very important point, and you want to make sure that you write that down. So what you want to do is make sure that you measure that. Most of the GPS equipment will have a tape measure built inside their boxes, or even mounted on the tripod that will allow you to get that measurement. In this particular one, it's telling you that it's measuring on the slant, which means it's measuring from the side of the unit down to the point as opposed to directly below it. Some of them will be able to meet directly above it, and you want to make sure you do that. This is where you would import that data. Then at that time, I would want to hit, at this time, we're going to have it find itself. So we're going to tell the GPS to auto position. So I hit the auto position button, and when I hit the auto position button, it finds itself. We happen to be working in the WGS 84 system here, the World Grid System 84, and this is you notice we're getting a latitude and a longitude and an ellipsoidal height. So just want to know this is a north latitude, and this is a west longitude as indicated by the negative sign here. Finding its auto position, my ellipsoid height is 1170.734. So we tell it to go ahead and start the base. The base is set. You'll usually hear some sort of a signal when it finds the signal, and it's based in its broadcasting. And then there'll be usually some sort of color coding system on your base unit, whether it's a blue light, and I believe the Lycon system uses a blue light to show you that it's sending the signal. The TopCon system uses a green light to be able to show you that the signal is going on. And then if you lose that, there's usually a color coding system or a flashing system that will go with that. You need to make sure you know what's particular to your system. Okay, now you got the rover set up, so now we're going to come over and we're now going to set up our rover. I'm sorry, our base is set up, and now we're ready to start communicating with our rover. So now we come into the rover and we set up our rover. So I'm coming into the rover, and the first thing I'm going to do is I'm going to set up my rover status, make sure that my rover is getting positioned. So I'm going to take my range rod, and in my next video series, I'll show you how to set this equipment up. I'm going to hook the GPS unit onto it with the rod. In this situation now, I will want to be getting our signal here. So it's imperative that I know my rod heights. That will all come in the setting up of your data collector. In this situation, again, we're doing the World Grid System. This is one that checks the status. Now, what this does is we're turning on the GPS, the roving unit, and we're saying, find yourself. So it's finding itself. And here's what happens is, as this gets more refined and finds its position, it's going to start giving you some data here that shows that you're able to do this. This is the TopCon system, but I'll tell you a little bit about what you're seeing here. You're basically seeing that we're actually using GPS and GLONASS satellites, and what it's telling us right now is that we're tracking 8 GPS satellites and 8 GLONASS satellites. Also tells us that our position is autonomous, which means it's not fixed. It hasn't found the base unit, and there's no communication with the base unit just yet. So right now, this is an autonomous position, which means this position it has some plus or minus factors on it, and it is roaming out there, and we want to make sure that we get a fixed position and a lock with our base unit. Here's our ellipsoidal height, or at least while it's trying to work its way. Over here, my PDOP stands for my dilution of precision here, and the PDOP, I don't remember right now what the acronym for that is, but it does tell us that it's 2.3. So we want to get that number down a little bit closer, so our precision is a little bit better. Right now, it's telling us that our horizontal accuracy is about 13 feet. Our vertical accuracy is about 15 feet. Well, obviously, in survey grade point data, that's not anywhere sufficient for us. So we would have to get that defined down. So how do we do that? We're going to do that by holding together. We're going to hold our rover in a good position, making sure that we don't have any encumbrances from the sky where we might be having like a building coverage, or under a building, under a bridge, something like that, where I want to make sure that I'm getting a good view of the sky so that I could be tracking the satellites that are above me. Once I go through here, it's going through and it's going to start processing. And most of this is done on its own. If you are having trouble, there is a way to reset your RTK, similar to what we talked about in the earlier, where I said you could either do a reboot by turning it off or on, or this is what I would call a soft reboot, where you can soft reboot it and have it go back and try to find everything. So in this situation now, we're starting to find. It goes through, and now if you notice right here on our screen, it's telling us that it's connected to our radio link. We're 100% connected to our radio link, and we are good quality. I'm not sure where the manufacturer came up with 2,000%, but anyway, just telling us that we're really good to work and go ahead and work right now. Now that we've initialized our satellites, must be 5 or more. Remember to do this. So we do have our satellites. We're having a common satellite readout, and we're able to track the number of satellites. So therefore, we can in fact be able to get a fixed position. So now your GPS, and this is all taking place in seconds here, as a matter of fact, and we're going to get to a point where we actually says our position is fixed. So now that we have a fixed position, we're ready to start collecting data. So that was where we needed to go, and actually that would be how we know we are ready to collect position, and we're talking about our actual positions now. So now I'm going to progress through and make sure that we understand that we're in the right system, coordinate system, so that we can in fact be able to get coordinates in the system that we're wanting. So I'm going to come over here, and we're going to talk about coordinates. Now, in this particular section, we're going to talk about different coordinates and bringing coordinates into the data collector. So let's say that we already have a bunch of control points. We want to make sure that our data collector has them in there so that we can put them in there. For example, we may know that base says system, or we may not, but we want to bring in some points. So here are ways you can bring the points in. You can come over here into your job screen right on your data collector, on your data controller, somewhere within the data controller, whether it's the Leica system or the TopCon system. And what you would do is you would scroll through and get to where you can import some points. Here we're talking about importing points. I'm going to bring them in from a file. I can either bring them in from a computer-based file or a jump drive or some sort of technology like that. And I bring in the points. Here I'm talking about, okay, I'm going to bring in points. They're going to be design points or control points. There may be whatever I want to call them, and how I can control them and bring them in by text. And now we're importing our file. They're going to come in as text files here. We could customize that format. We could be bringing in Excel files, whatever we want to do in our situation is coming in as text. And our file format may look something like this. We did discuss this earlier in the semester. This is a PNEZD a data file, meaning that the first column here is point numbers. The second column is north coordinates. The third column is easting coordinates. The fourth column is elevations. The fifth column over here is descriptions of the points. So this is, and they're all separated by commas. So this is a comma delimited PNEZD file in US feet. Point number, northing, easting, elevation, and descriptor file. So that is the way our data is coming in. Our data is in our system. So we could import those points, bring those in as text points. And now that we are sharing, notice right here, we're talking about our comma delimited file. We're bringing that in. That now brings them in, and we're now bringing those in, importing those points in. We can tell whether those are grid coordinates or ground coordinates at this time, whether or not there's a geoid selected, and we can bring that data in. Another system might be is that we don't actually have any points, and we're going to find our own system. Well, that means that we can do a localization system and actually work our system in. We can take the system on the fly, just collect the data as whatever the GPS unit gets us, and then correct up later. That's called a localization system or an assumed system. We could also go out and find some of the state plane coordinate datum system. We did talk about the NAD 27 earlier in the semester, the NAD 88, which is the North American Datum System of 1927, or the North American Datum System of 88. You can actually be talking with your client and whoever you're sending the data to see what sort of system they want that in. Again, those are all onboard options within the collector, and you could actually set it up for yourself. So this is how satellites see the Earth. Imagine here we're looking down on it, and the satellites are rotating in a constellation here around the United States. The majority of the satellites will be rotating here around the equator, and up north, not a lot of satellite coverage up over here in the north, both the North and the South Pole, since most of the inhabitants basically set right here, either north or south of the equator. So this is how satellites are actually tracking. So we are getting our information from them. So how does a coordinate system work? Well, basically what it is using a series of measuring the time it takes for the satellite signal to get to the receiver and back. It uses that distance to compute its distance. Once we have the distance of that point, using a very sensitive clock called an atomic clock, once we get that distance, we are then able to pinpoint that position. And then when we have multiple positions of that, we're able to form a triangle. By using a series of triangles, we're able to calculate and form a correction for our position and find our position on the face of the Earth. Remember, the satellite knows where it's at, so therefore, and it's very meticulous in sending out the signal, so therefore we're able to calculate the point. And then, but now we have to talk about how are we going to do it when we work on a map. Remember, the Earth is a sphere. The ground, most of the coordinate systems we're working in are flat or in a Cartesian coordinate system. So there's a correction factor, and this next slide sort of shows us what we're doing. Here we are down on the surface of the Earth, but realistically what we're doing in our projection and our calculations is using a flat grid. If you remember, we talked about this earlier in the semester, and I told you that the title of your book is Geodetic and Plane and Geodetic Surveying. Geodetic surveying is here when we're taking into consideration this curvature. Plane surveying is what we actually do in most of our jobs. This is because most of our jobs are small enough in size that we can control them internally. So this is what we call a grid system. So here we have geodetic and grid, or ground and grid coordinate system. So this is how we calculate our points. And now the rest is really easy. The GPS system itself will go through, calculate the coordinates. The important part for you is to make sure that you are accepting the points. And if you're accepting the points, you're able to click to save that point or not, or choose it however you want to do and set it up. Key thing for the user or the end user is that you know what coding system you want to work on, what sort of codes you're putting on, and the numerical values will be associating with it. The one thing that's really pleasing, I guess, about the GPS is that there's no computations done on the user standpoint. It's all done internally within the GPS. If the satellite position isn't good enough, the GPS probably isn't going to give you a position. And it's going to be your responsibility to decide whether or not your data set is sufficient enough to compute and give you a good point. So here is what the system would look like. This is what ground coordinates would be. This is what grid coordinates would be. So basically, we may have on the over here on a coordinate system, on the ground system, we may have latitude, longitude, and ellipsoidal height, and then we will do the conversion factor so that we can get it into a localized grid system, which would be a rectangular system of northing, eastings, and elevations above or below this plane. A few things to just sort of round us up at the end. What is, so in many of the trainings I've been to, I found this as being one of the most important slides I can always say for students and give advice to people who are going to be using the equipment. I think the best way to ensure great work using the RTK GPS system is, first of all, making sure that you are accurate. And with accuracy, sometimes speed is not, you're not able to get it quickly because you're trying to be accurate. But you can, in fact, get good and be able to do it quick, but you need to make sure that you understand the system well enough to do that. So my advice is to make sure and work with that system. The system is pretty foolproof and can allow you to be a very functional user right away. The difference is we're not sure about what you are doing. I always like to say, for accuracy, is find yourself a point, know where you have a point or two or three or four on the job site that you're comfortable with, and then make sure that you always try to find that point back and forth all the time. I usually will pick a point, save that point, then throughout the survey project, I'll keep going back and restaking out that point, and it should navigate me back to that point. So when setting up control or doing any type of survey, you do it similar that you would do as if you were doing it conventional versus the GPS system, or any way you'd be running a survey crew, is that you make sure that that you always have precision. You're able to repeat your work and do it again and again, because then you know that your work is accuracy. Therefore, if you have precision and repeatability in your work, you have confidence in your answer. And remember, that's what it is. The disadvantage, one of the biggest disadvantages I found in the GPS when I have moved throughout the years of progression for survey equipment, is the GPS is one where I really can't do a mathematical check. So you really have to rely on the GPS itself to give you the quality numbers. So word of advice, please be precise and repeat, and make sure that your work is repeatable by being as accurate as you can and taking the time to understand your equipment. That being said, I want to say, be careful, be disciplined. This is only a tool, and it's only as good as you are. So you need to plan your job. You need to write things down, and you need to take your time to do it right. And basically, basically always communicate with both your whoever wants the data and whatever they're expecting to get, so that you all know what you're doing. The technology is wonderful. You're able to set it up in all sorts of different ways, but you want to make sure that you all are talking the same language. That being said, that will end my slide for video 2 on how to use GPS and data collection. Thank you. This is Professor Minzik coming to you, and I will be talking with you again at a different time about how to set up equipment. So this is video series 2, or video 2 in module 5, I believe, and this is how to use surveying equipment. Thank you, and look forward to talking with you again in the next video series. And I am going to